Let us now take a look at reactions of acids in aqueous solution. The most common feature of these reactions will have something to do with what is common among acids. And what's common among acids is that these acids have uh, hydrogen ions that dissociate from the acid molecule and attaches itself to a water molecule called hydrogen, and you get what's called hydronium. Okay, so H plus water gives you a hydronium ion, which is whenever we talk about H plus in aqueous solution, what we really mean is the H plus that's attached to the hydronium ion, to the water molecule in hydronium ion. Okay, so a common feature of these reactions, if you want to be able to make predictions, is to realize that this H plus would be attracted to something negative. So it will combine with, it could combine with a negative ion, an anion from another reactant, or it can attach itself to a lone pair on a molecule that might be in solution. Most molecules that would have this have a nitrogen atom that has a lone pair on it. So for example, ammonia, for example, okay, NH3 has a lone pair that can be can can form a covalent bond with an H plus. All right, so here's some examples. An H plus from the acid can combine with an oxide ion, O negative 2, or a hydroxide ion to give you a water molecule. Okay, the H plus from the acid, like I said, can react with a negative ion. Okay, and this will occur to a significant extent only if what you can make is what's called a weak acid. If that combination leads to a strong acid, then we know it's just going to fall apart right away, so that's not going to be a significant reaction. Okay, so the anion, if this anion is a conjugate of a strong acid, you can just ignore that. Okay, so you say there won't be a reaction with H plus. Now, if that weak acid that you're making happens to be carbonic acid, H2CO3, you may observe further reaction. The carbonic acid decomposes to carbon dioxide gas and liquid water. So this carbon dioxide gas, you'll observe this as an effervescence. It will bubble out of your solution because depending on how much, if you get a lot of it, then carbon dioxide has a limited solubility in water. So you see this effervescence, which you might in layman's terms call a fizz. If your weak acid happens to be sulfurous acid, H2SO3, so that's what happens when you combine H plus, 2H plus, and a sulfite. That gives you H2SO3. Then that H2SO3, if you get enough of it, you may observe the formation of SO2 gas, and this has a very sharp smell. Okay, and that's the way you can detect that in the lab. Okay, and of course H2SO3 here, the other product would be H2O. So that's a decomposition reaction. Sulfurous acid gives you SO2 gas plus water. Now, you do need to be aware of the possibility that the negative ion from the acid itself may react with a positive ion from some other reactant in your solution, and that could give you a precipitate. So those are the common reactions you might expect if you have an acid and you react with something else in aqueous solution.